Hello friends. So let's talk about the vanishing gradient descent. So in RNN, as you have seen that we are passing our information of a one layer of a one timestamp to the nth timestamp. So let's take an example of a text analytics. In text analytics, if we have a small sentence, then or a 5-word sentence, then it would be very easy to get information from an first layer to the nth layer, right? But if we have a long sentence and during the back propagation, suppose if I'm having a 100-word sentence, now when we are at 100 word, to collect the memory from the first word itself and doing the back propagation, my weight is getting because the weight is gradient descent is very small, right? So when we'll multiply this gradient descent within a small number, the small number would generate, and again at a layer when my this gradient descent would be multiplied with a smaller number, so it is diminishing very slowly, right? So if you see the neural network over here, and if we're having a very depth neural network, in that scenario when you go and do the back propagation, you will see that the first layer or the second layer would not be getting learned from the gradient descent, because gradient descent is diminishing it, right? Because it is at every layer it would be multiplied by the small number, and that number would become smaller, right? And smaller and smaller, and at that time, when you reach to the first layer, you will see that your gradient descent is so small. So when you are updating a weight, though your weight is not getting updated that significantly, and your layer would not be able to learn. So this is the problem what the RNN is also facing it. And for this, the solution for this we can discuss further during the LSTM. So the LSTM is a solution that is a long short-term memory, which helps to prevent it from the vanishing gradient descent. So another problem with an RNN is the exploding gradient. So in case if our learning rate is high, or if our weight, if we have initialize it at a very high number, right? It is as we have seen in a weight initialization, that we need to initialize the weight either with a normal distribution and all. But if somebody initialize the weight with a high number, or the learning rate is very high, then the gradient can get a very large. Even when they multiply them with the learning rate, they can cause a loss and a weight to the heavy fluctuate. Okay, so in this scenario, if you'll see over here, previously my weight is over here, then it fluctuates from here because my learning rate is too high, then it goes here, and then it would reach somewhere else. So it would not be easy for the weight to reach to the global minima, right? So it will fluctuate here and there, and the accuracy would not get what we are expecting it. So the solution for this is a gradient clipping. So what clipping does, it clips the gradient to the specific value when they exceed a specific threshold. So if we'll see that my gradient value is greater than 0.5, then we'll convert it to 0.5. We clip it in 0.5. And if my value is less than 0.5, then we'll keep the same value. So if my value is exploding, we clip it and bring back to the smallest one, that is 0.5. So that's how we can reduce, or we can eliminate the factor of an exploding gradient descent, right? So thank you guys. These are the two issues what we are facing it in RNN structure. Now going forward, we will be studying about the advanced recurrent neural network, or another component of a neural network, that is the LSTM, bidirectional LSTM, and what are the advantages and what are the other use cases application we will be using it during the LSTM. Okay guys, thank you.